Saxon's Calculus, Lesson 53 is about area under a curve. And this is the main application of calculus and why we learned about integration. But I'll get into that part in just a moment. So they remind us from way back, when we find the area of a rectangle, it is length times width. And then what we're doing here is I've drawn a curve and I'm saying the calculus part of this is finding the area underneath this curve. It's not a true rectangle. If I cut it off here, I would have extra space above it. And so if I use the concept of the integration in calculus, I can find the area underneath this curve. Now, to do that, you see here that I'm talking about the section between, let's say, A and B as they were doing on page 261. On page 262, they show you a different curve in which they're actually starting here with the y-axis and going all the way. And then they show you that they're dividing this into multiple sections. And the tighter the sections that are drawn, the more accurate the area of the curve will be. Now, to get the actual rectangles that they're talking about, you have two options. I can either cut them off underneath the curve as tight as I could to the curve, or, as I'm going to do in this one, I can extend this up and then come over, which is giving the area above it. So where this dot hits, it's going over and down. That's a little more accurate. So I can have either underneath the curve or the rectangle slightly above the curve. Whichever way I choose to do it, I have to do the same. Keep them all underneath or all above. And you're seeing those examples on page 262. And then, if you're still following in the book, they show you that once you find the area of each of these rectangles, you're going to add them together. So, before I get to that, on page 263, they talk about this gap that you have either above or below. That is your error level. And so the wider your rectangles, the worse the error is going to be. The tighter the rectangles, the less the error will be. And then on the bottom of 263, they say that rather than saying we're just going to add all these rectangles together, they give you the summation notation, which is why they reviewed that in a lesson earlier, for basically the f of x with the change in x multiplying together there. And when you do that summation notation, you're getting the area under all of the curves. Then mathematicians determined that when they did this summation, remembering that their boundaries went from A to this end line B, they said, wait a minute, we get the same thing if we integrate from A to B the function, whatever it was, of f of x that created that curve with the dx. So this is the calculus way to find the area under the curve rather than using the summation notation. Now that we have that, they don't have us go through any examples, but they say that this formula will now stand alone and you don't have to do the graph anymore, just jump straight into the equation. And that is all of lesson 53. I believe they get into the examples. Well, let me see. Is it in lesson 54? Nope, but they do get into them.